Here. Okay, so it's 3 o'clock. I think we can go ahead and start, okay? So yesterday we were talking about the Rutherford's model of the atom. We started the chapter atomic structure, and we were talking about the different properties of the atom. Like, I mean, we know that the nucleus, it contains a central nucleus, which has protons and neutrons, and around them are orbiting electrons. But that was a Thomson's model. Thomson's model was different. It was initially about this plum pudding model, okay? Just the protons are, there's a unique, positively charged matter, and within that is spread, electrons are spread throughout that material uniformly. But that was not correct model. And then Rutherford came and he did this experiment, he and Geiger and Marston. At the suggestion of Rutherford, Geiger and Marston did an experiment with alpha particles bombarded to a gold, passing through a slit in a lead sheet, and then bombarding a gold foil, thin gold foil, and then some of the atoms would just reach the zinc sulfide screen, and some would be deflected. Most of them would pass through. Some would be deflected at large angles, like this one. Then they would reach the zinc sulfide screen where they would produce flashes of light, and then the microscope would be there to detect the flashes of the light, to detect the alpha particles. So we talked about the Rutherford experiment, and he basically came up with this Rutherford scattering formula, okay? And today we're going to do the derivation of this formula. That is our goal for today. So what does this formula say? N theta, N is the number of alpha particles per unit area that reach the screen at a scattering angle of theta. Theta is our scattering angle. So basically, if we have this is the incoming direction of the alpha particle, then theta is the angle between the line of the incoming alpha particle to the line of the deflection, okay? So theta is that angle. And then n theta is the number of alpha particles per unit area that reach the screen at the scattering angle theta. So we have to come up with this formula. We have to derive this formula, which says that where n is the number of alpha particles per unit area that are reaching the screen, and n, it is in terms of these other variables here. Theta, as we know, the scattering angle. Ke here is the kinetic energy of the alpha particles. What is R here? R is the distance of the screen from the foil. So if we have an experiment that is like this, R is the distance of the screen from the foil, okay? So if it's like a circular, if this is like a circular zinc sulfide screen, then it would be the radius of the circle, okay? So then Z is the atomic number of the Z here is the atomic number of the foil atoms. N is the number of atoms per unit volume of the foil. T here is the thickness of the foil. And NT is the total number of alpha particles that reach the screen. So we have to derive this formula. So let's start by, yesterday we made some 3 assumptions regarding Rutherford's model. Okay? What were those 3 assumptions? It said the alpha particle, one assumption is that the alpha particle the nucleus interact with are both small to be considered as point masses and charges. So the alpha particle nucleus, they both are very small enough that we can consider them as point masses and point charges. Okay? Number 2, the second assumption was that the repulsive electric force between the alpha particles and the nucleus, which are both positively charged, because I said, remember that the alpha particle, it is a helium nucleus which has lost 2 electrons. So it's also positively charged. The nucleus is obviously positively charged. So basically we have the repulsive electric force between those 2 positive charges. And that is the only charge that is acting, okay? That is the only force that is acting. That's our assumption, that the repulsive electric force is the only force between those 2 particles. And then the third assumption is that the nucleus is very massive compared with the alpha particle, that does not move during their interaction. And the nucleus is so much more massive than the alpha particle that it does not move during the interaction. The nucleus is stationary. The alpha particle is the only particle that's moving. So now we want to talk about the scattering. Did anyone have a question? No? Okay, then we'll continue. So what is the scattering angle?
मैम मेरा क्वेश्चन है लेकिन वो क्वांटम से है तो जब आप ये वाला टॉपिक खत्म कर लेंगी तो मैं आपसे पूछ लूं
Sure, anytime. Okay, so scattering angle. Now, what we're saying here is that we will talk about we will give some important terms, okay? So owing to the variation of the electric force varies with 1 over r squared. We know that, right? Electric force is inversely proportional to r squared, where r is the distance between the two charges, okay? So that we know about the electric force, and r is the instantaneous separation between the alpha particle and the nucleus. So what is r here? R is the distance between the alpha particle and the nucleus, okay? And the alpha particle's path is hyperbola with the nucleus at the outer focus, ठीक है? So alpha particle, अगर यहाँ पे हमारे पास nucleus है, target nucleus ये है, ठीक है? The alpha particle is going to come close to the nucleus and then it's going to deflect, ठीक है? It's not necessary that it's going to be on right in line with the nucleus, ठीक है? There are lots of alpha particles, so we don't like it can be like this is our diagram for the scattering, okay? And we will define some important terms here, the impact parameter B and the scattering angle theta. So as I mentioned before, the scattering angle theta is the angle between the line of incident path of the alpha particle to the reflected path of the reflected path of the alpha particle. So this we have the theta angle here. And then we define something known as the impact parameter B, which is the minimum distance to which the alpha particle would approach the nucleus if there were no forces between them. So B, as you can see over here, if we extend the incident line, the line of, what do you call it? The incident path of the alpha particle, अगर हम इसको extend करें, तो the perpendicular distance, the minimum distance between this path, incident path, and the nucleus is known as the impact parameter, which is we define it as B. We write it as B as the impact parameter. It's defined as the minimum distance to which the alpha particle would approach the nucleus if there were no forces between them. Is that making sense? Like if there were no forces between them, the alpha particle would just simply go straight through. So it's the minimum distance, which is this distance B. Okay? So this is known as the impact parameter. And the scattering angle is the angle between the asymptotic direction of approach of the alpha particle and the asymptotic direction in which it recedes. Now what we want to do is we want to find a relation between B and theta. That is our first task. Okay? So far, makes sense, everything? And scattering angle is the path between the direction of approach and the asymptotic.
Excuse me, ma'am.
Direction of yes.
मैम ये इम्पैक्ट पैरामीटर को किस तरह डिफाइन कर रहे हैं ये जो हम
Impact parameter is the minimum distance to which alpha particle would approach the nucleus if there were no forces between them. यानी कि अगर कोई electric force ना होती तो ये जो alpha particle है it would just keep on going on its incident path, right? So the minimum distance, यानी कि अगर मैं draw करूँ इस board पे, if we have, this is our nucleus here and this is our alpha particle. ठीक है? And the alpha particle, this is the path of the alpha particle, it deflects like this somehow, ठीक है? जो भी उसका path है, but if it did not deflect, it would go straight through. If there were no force between them, it would go straight through, and the minimum distance will not be this distance. It will not be this distance. It will not be this distance. The minimum distance is the perpendicular distance, ठीक है? So this distance, this is our impact parameter B. Make sense?
Yes, ma'am.
It is impact parameter is the minimum distance to which the alpha particle would approach the nucleus if basically there were no forces between them. That is how we define the impact parameter B. I hope this diagram is clear, it's big enough to be observed, to be seen, okay? So now what we're doing is that we want to find a relation between this B and theta, okay? That is our first goal, and let's see what the result is, then we will go about deriving it, okay? we have to do some lots of calculations and like we have to do a lot of calculated work here, okay? So this is our relation between B and basically this equation here, 4.29, is a relation between B and theta, and we're going to derive that now, okay? So how do we do that now? Now let's look our first, as a result of the impulse, now we're going to look at momentum conservation, okay? Momentum hum dekhenge pehle. And we all know by Newton's laws, Newton's second law, that force is the rate of change of momentum, right? Force is the rate of change of momentum. So dp dt, yes? In other words, P, you can write P, the change in P as the integration of F with respect to time, right? And this is the change in the momentum, or in other words, this is the impulse of the force, right? The force times the distance moved, force times the time taken for that force, and we take the integration because the force can be a function, right? So we take the integration of that with respect to time. So force can be a function of time as well. So whatever the force is at the instantaneous time, we multiply it, then we take the integration over that. Is that making sense? Like, jo function hai, f can be a function of time. So we take the integration of the function with respect to time, and that would give us the change in the momentum, which is the impulse of the force. Okay? So that is how we define it here. We are saying this thing here. So then, why are we using this here? Because the alpha particle. We're saying that because the nucleus remains stationary, we made an assumption here that the nucleus remains stationary throughout the passage of the alpha particle. So in that situation, the alpha particle kinetic energy is the same as before and after the scattering, right? Because obviously if the nucleus is stationary during the passage of the alpha particle, its kinetic energy would remain the same before and after the scattering, which basically should be 0, right? We don't assume that its kinetic energy, the nucleus remains stationary through the passage of the alpha particle. The alpha particle kinetic energy is the same before and after the scattering, okay? Because we assume that the nucleus remains stationary, so the nucleus is stationary throughout. So it's obviously, so the alpha particles, we're saying the alpha particles kinetic energy will remain the same before and after the what do you call it, the scattering. Is that making sense? So the magnitude of the momentum is the same before and after. We know that momentum is equals to P is equals to mv, right? And we know that kinetic energy is equals to kinetic energy is we know it's half mv square, and we are not using relativistic calculations here right now. So you get half mv squared. So basically if the kinetic energy is going to remain the same, then the momentum is also going to remain the same. P1 is equals to P2 is equals to mv, okay? So we're assuming that because the nucleus is stationary throughout the passage of the alpha particle, therefore the alpha particle kinetic energy is the same before and after, and hence the momentum is also the same before and after. Now now I'm going to first explain you this diagram over here, ठीक है? इसको मैं थोड़ा सा बड़ा कर देती हूँ ताकि नजर आ जाए अच्छी तरह से, ठीक है? I will first explain this diagram here, and then we will go on to use the sine rule, law of sines from this diagram, ठीक है? So, for example, if we have the nucleus over here, ठीक है? यहाँ पे हमारे पास path of a particle है, ये ऐसे जा रहा है, ठीक है? So, we define this theta here as this angle. You know, we define theta as the incident path, the angle between the incident path and the scattered path, right? So this is our theta. And then जो बाकी angle है, ये जो angle है, इसको हम divide by 2 parts कर देते हैं. But this whole angle that is remaining is pi minus theta, right? Because this, if the alpha particle was to go straight through, then that would just be pi angle, right? So this angle here is pi minus theta, and then we divide it into 2 parts, and this becomes half pi minus theta, and the other part becomes half pi minus theta. So now we're drawing, now Now our this line over here is the direction of the initial momentum, and this path is the direction of the final momentum, P2. Initial momentum we say P1 and final momentum we say P2. And why is it like this? Because the momentum obviously takes the direction of the velocity, and the velocity is in this direction here and this direction here. So we draw a triangle like this, ठीक है? हम इस तरह से पैरेललोग्राम बना लेते हैं यहाँ पे, जिसमें ये है P1 और ये this, because the parallelogram has the parallel sides are equal. This side is P1, this side is also P1, this is P2, this side is also P2. ठीक है? And according to this this diagram, this angle over here is equals to half pi minus theta, because it's this angle here, which we already said, because this whole angle is pi minus theta. Since this angle is theta, we divide it into two halves, and then this will be pi minus theta divided by 2, and this will be pi minus theta divided by 2. So we have those two angles here. This angle is half pi minus theta, and this angle here is also half pi minus theta. And then this angle over here is going to be this angle, right? Because it's the angle between the, it's basically, if I draw another diagram, I don't know, can you all understand the PowerPoint clearly? Like, this is our parallelogram, right? So basically, this side is P1, this side is P1, this side is P2, and this side is also P1 because of their parallel triangle, like this side, because it's equal in length to this side, right? So it'll be P1 in magnitude, and direction is the same. And this will also be P2. ठीक है? And then this, if we draw it like this, this angle here, this angle is half pi minus theta. Pi minus theta, ठीक है? And this angle, because it's equal to this angle, right? And we said that this angle is theta. So this angle will also be theta. Is that making sense? Because we said that the scattered angle is theta, right? The scattering angle is theta, so therefore this angle is also theta. So now if we understand this triangle and this diagram, we can apply the law of sines. So delta P now what is the direction of delta P? Now if we have this and this, delta P will be which direction? P2 minus P1, right? So it'll be this direction. You must have studied vectors in maths courses and maybe FSC or A levels, ठीक है? If this is the direction of P2 and ये P1 हमारे पास, ये P1 इस तरह है, but P2 minus P1 will give you the delta P, right? Delta P. So I mean, जब vectors add करते हैं, तो एक के head पे दूसरा डाल देते हैं, right? Here we get the third
मैम लेकिन
side.
ये जो चेंज इन मोमेंटम जो वेक्टर शो किया हुआ है, ये तो गलत शो किया हुआ ना?
क्यों?
मैम इसकी जो रिजल्टेंट की जो डायरेक्शन होगी वो टुवर्ड्स P2 की तरफ नहीं होगी?
नहीं,
अगर हेड टू टेल रूल के अकॉर्डिंग अगर देखा जाए,
in the momentum. P1 plus change in momentum is defined as P2 minus P1, ठीक है? Change in momentum is defined as P2 minus P1, right? So P2 vector is this vector, and this is P1 in this direction, but we will take this direction to be minus P1. And then it's when we combine it, when we draw the arrow from the tail of one to the head of the other, we get delta P. Make sense? Change in momentum. ये आपने पढ़ा होगा ना, tail of one to the head of the other. Combine those two, you will get the sum of P1. For example, if you have P2 here and P1 here, this is minus P1. ठीक है? Then this will be the change.
मैम,
Yes?
मैम ये जो आपने P1 वेक्टर एक रेड कलर से बनाया नीचे की
हाँ,
तरफ, ये टुवर्ड्स राइट है, लेकिन वही जो ऊपर आपने ब्लू कलर में बनाया वो उसके ऑपोजिट कर दी है। ये किस तरह? डायरेक्शन तो सेम रहेगी।
ये कुछ और है. Just leave this one. Basically P delta P is P2 minus P1, ठीक है? P1 is in this direction and in this direction. It's equal to this vector. This vector is in the same magnitude, length, and same direction as this one. So this will also be P1, but we want P2 minus P1. So P2 and then plus minus P1. ठीक है? Plus minus P1. इस तरह से करते हैं, ठीक है? तो इस P1 को flip कर देते हैं दूसरी साइड पर माइनस हो जाएगा ना, minus P1 हो जाएगा when we flip it the other side, and then we take the tail of one and connect it to the head of the other one, then we get delta P. Make sense? Yes?
Yes, ma'am.
Okay, so now we will use this diagram here and we will use the law of sines, which you know that is, are you all familiar with the law of sines? Sine over sine, let me just look at this again. Delta P, which is the length of this side, divided by sine theta, this side divided by, you must be familiar with the law of sines. हमने वो पहले भी पढ़ा था, I think proper motion में, when we were studying one of the previous courses, ठीक है? Sine A over sine, sorry, wait a minute, I think this is small a, ठीक है? Wait a minute, इसमें क्या है? Sorry, इसमें delta P over sine theta is equals to mv over sine pi minus theta over 2. ये किस तरह से हमारे पास आया है? Basically, if we look at this diagram, ये इस diagram को देखें, this is delta p, ठीक है, divided by sine this theta is equals to p2, which is mv divided by sine of this angle. ठीक है, so it's length divided by sine of the angle it subtends at the center divided, so it's basically sine A over A. I think it was like this. What was the sine rule again? Does anyone remember? Let me just, law of sines. Law of sines.
Ma'am, A over sine
It's
alpha is
this
equal
one.
to
Yeah. It's A over sine A alpha is equals to B over sine beta, ठीक है? This is our law of sine. So if I copy this image and put it in this PowerPoint, that would be helpful. ठीक है? Oops. Yeah, here. So we have this. Well, I will just delete this because it's not going to be. I think you all know this law of sines, ठीक है? So it's basically this law, ठीक है? A over this length divided by sine of the angle it subtends at the center, the opposite angle, is equals to B, the length, is equals to B divided by sine of the angle, opposite angle to the angle that's opposite to that length, is equals to C, this length, divided by sine of this angle. So according to the law of sines, we can say that using this parallelogram over here, we'll say that delta P divided by sine theta, delta P over sine is equals to P2, which is equal to this side, right? I said that this side is also equal to P2 divided by sine of this angle, which is half pi minus theta. So here we get this. Yes?
मैम पिछली स्लाइड पे जाएं।
ये वाली?
नहीं जिसमें वो एंगल शो। हाँ जी मैम, आप जो वो रूल बता रही हैं, हेड टू टेल रूल, वो वैसे तो समझ आ रहा है, लेकिन ये जो छोटी सी डायग्राम बनी है P1 और P2 वेक्टर्स वाली, जी, इसमें अगर हम P1 के स्टार्ट से डायरेक्ट P2 के हेड पे ले जाएं तो वो गलत होगा।
But we want P2 minus P1 basically. We don't want P1 plus P2. Yes, वो गलत होगा।
ओके मैम,
ठीक है, because हमें P1 plus P2 नहीं चाहिए, हमें P2 minus P1 चाहिए, इसलिए। ठीक है? So we use the sine rule and we get this formula. इसको अगर हम, we know that sine cos theta over 2, ये sine A plus B है ना, sine A plus B, इसको expand करें तो हमारे पास क्या आता है? Sine A plus B is equal to sine A sine B plus something like that, right? This one.
Excuse me, ma'am.
Yes?
मैम जो P1 और P2 वाला केस है ना, उसमें ये है कि हमने इसकी डायरेक्शन ऑपोजिट की है ना, उसको ऐड करने के लिए, रिजल्टेंट वेक्टर निकालने के लिए, तो इसलिए भी माइनस है।
Yeah, ये माइनस इसलिए है because
क्योंकि
we're doing
डायरेक्शन
P2.
ऑपोजिट की है इसको ऐड करने के लिए।
Yeah, so I said P2 plus minus P1, right? So P2 plus minus P1, minus P1 करेंगे तो फिर उसको ऐड करेंगे. That's, yeah.
एक्सक्यूज मी मैम,
Yeah.
मैम पीछे हमने ये एज्यूम किया ना कि बिफोर और आफ्टर जो है मोमेंटम सेम है,
Yeah.
तो ये जो इसका रिजल्टेंट होगा डेल पी, ये वेक्टर क्या जीरो होगा?
No, because direction matters, right? Uska magnitude, iska direction matters, right? So we cannot just make it equal to, zero because direction is important here. And then we have here, now we have sine 180 minus, ये जो sine half pi minus theta है ना, you can write this as sine pi over 2 is half को इससे multiply करें, it will become 90 minus theta over 2, right? Sine 90, यहाँ पे तो we have half times 180 minus theta, 180 degrees. तो इसको अगर हम लिखें sine, it becomes, ये जो half है इसको दोनों तरफ से multiply करें, दोनों terms से, तो we'll get sine 90 degrees minus theta over 2. And we know that sine 90 minus theta over 2, for example, is equals to cos, sine 90 minus theta is equals to cos theta. तो इसलिए हमने इसको cos theta over 2 लिख लिया. ये समझ में आ गया ये किस तरह से लिखा है हमने? So basically now, and we also know that sine theta is equals to, can be written as 2 sine theta over 2 times cos theta over 2, ठीक है? So basically, इसकी जगह हमने, इस formula की जगह हमने cos theta over 2 डाल दिया है, and cos, and ये जो sin theta है उसको हम लिखेंगे 2 sin theta over 2 cos theta over 2. थोड़ी सी algebra करेंगे, ये पहले इस sin theta minus theta pi, sin pi minus theta over 2 को cos theta over 2 लिखेंगे, फिर ये जो sin theta है उसको इस तरफ ले जाएंगे, it will be mv sin theta divided by cos theta over 2. ये समझ में आ रहा है? And then sin theta को expand करेंगे, फिर नीचे denominator का cos theta over 2 will be cancelled with the numerator cos theta over 2. Then we will basically get this formula. ठीक है? It's just some algebra. You have to use these trigonometric identities into this formula, and then you will get this formula eventually. ठीक है? So now we have a formula for delta P in terms of theta and v, ठीक है? The velocity of the particle, the alpha particle. Here v is the alpha particle velocity, ठीक है? And now the impulse is in the same direction as the momentum change. Its magnitude is given by this, ठीक है? And why are we doing this here? It's because we know that the change in momentum is equals to the impulse, right? So we have to find an equation for the impulse, and we know that impulse also, because change in momentum is a vector, impulse will also be a vector because it's the integration of the force. So the impulse is in the same direction as the momentum change. So if we go back to this diagram here, the force, if the alpha particle was at this point and the nucleus is here, the force would be this direction, right? The force would be is a repelling force. So if the alpha particle is over here and the nucleus is here, then the force would be in the opposite direction. A force on the alpha particle will be away from the nucleus. So then, but the change, what we're saying here is that the impulse, which is equal to change in momentum, has basically, because we had this formula here that impulse is equal to change in momentum, this momentum, the change in momentum, the impulse should be the same direction as that of the change in the momentum. So basically we have to use magnitude of f dt integration is equals to f cos phi, where here this is the phi is the angle between the force and the change in the momentum. Because the impulse is in the same direction as the change in the momentum, is f को हम cos phi से multiply करेंगे तो फिर ये same direction इसके direction हो जाएगा. So we have to multiply f with cos phi dt. So the impulse, where phi is the instantaneous angle between f and delta P along the path of the alpha particle. Okay? Now what we're doing is that we have this equation, we have this equation, we have this equation, and we had our previous equation. We will equate this formula and this formula, and now let's see what we get. ये हमने equate कर दिए ये दोनों formulas को, इस formula को और इस formula को. We get something that looks like this, ठीक है? Now what we want to do is that we are taking the integration from minus infinity to infinity. Now we want to solve this. We want to change the variable from the right, from t to phi, because ये तो हमारे पास phi के terms में आ रहा है ना. और force की भी हम डालेंगे उसका force का जो quantity है ना वो भी बाद में डालेंगे हम. लेकिन what we want to do right now is that we want कि ये जो phi है, ये जो t और phi को हम relate करना चाहते हैं, ठीक है? We want to change the variable on the right hand side from t to phi, ठीक है? So let's see what we can do here, ठीक है? We will write this as dt divided by d phi times d phi will multiply and divide by d phi throughout, ठीक है? On this side, this side, and we know the limits of the integration will change from what to what. If we're taking it as the variable as phi now instead of time, then the phi is going from what angle to what angle? Minus pi minus theta over 2 to pi minus theta over 2, positive pi minus theta over 2, right? Because that is the maximum value for the phi can take, and this is the minimum value the phi can take, minus pi minus theta over 2. ठीक है? So ये हम डाल रहे हैं ये variables and we get this equation, ठीक है? ये सब यहाँ तक समझ में आ रहा है सबको? ये equation?
Yes, ma'am.
Okay. Okay, so the quantity d phi by dt is the angular velocity. Now we know that d phi by dt is the angular velocity of the alpha particles, right? We already know that d phi by dt is the angular velocity. So हम इसको कर देंगे d phi by dt is the angular velocity. So can we also, let's see now what else we have to do here. So the electric force exerted by the nucleus and the alpha particle acts along the radius vector joining them. Now, I was telling you before that this is a very long derivation and we have still more slides to go, okay? It's already a bit like a lot of things, okay? But we have more things. We have a lot of more slides to go for this derivation. But anyway, so I was saying that the electric force exerted by the nucleus on the alpha particle acts along the radius vector joining them. Basically, we have, this is the force, this is the, this is the radius vector joining them, okay? And here we will write here that m omega r square. What is the torque? There is no torque. The electric force exerted by the nucleus on the alpha particle acts along the radius vector joining them. So there is no torque on the alpha particle. Its angular momentum is constant. ये समझ में आ रहा है सबको क्या हो रहा है यहाँ पे? Basically, the electric force acts along the radius vector joining them. Basically, torque के लिए क्या होना चाहिए? Torque में we have perpendicular distance to the line of action of a force, right? If this is the line of action of a force, यहाँ पे कोई particle है, this is the force, ठीक है? So we have to, torque will be considered as the force times the distance, the perpendicular distance. I think it's a cross product, right? Torque, wait a minute.
Yes, ma'am, cross product है.
Cross product होता है ना, yeah. Like if, yeah, we have the torque here, so it's R cross F, okay? You have to consider the perpendicular distance. So you have to consider the perpendicular distance. So in our situation, so the torque can be written as tau equals to R cross F, okay? In our situation, what is going on? The force is acting along the line between those two particles, yes? So we will have no torque, basically. Yes? So there's no torque on the alpha particles. Angular momentum is constant. Okay? Basically, torque and angular momentum. Torque is what? Is an analogy to the force, right? Analogous to force in rotational motion. And angular momentum is analogous to momentum in rotational motion, right? So if the torque on the alpha, there's no torque, that means there's like, we consider that in the analogy to the classical, to the non-rotational motion, if there's no torque on the alpha particle, that means its angular momentum is constant, meaning that agar hum isko analogy dekhein, that no force on the alpha particle means its momentum would be constant, right? There's no rate of change of angular momentum. There's no rate of change of momentum. So in an analogous situation to the rotational motion, if there's no torque on an alpha particle, that means its angular momentum is constant. Ye pata hai sabko? Like angular momentum, change in angular momentum is equals to wait a minute. Angular momentum is the rate of change of angular momentum d by dt is equals to the change in the is equals to the torque, right? So if there's no torque, then there will be no change in the angular momentum. Is this formula correct? Yes, I think it is correct. Okay? Torque, because torque is analogous to force, and angular momentum is analogous to momentum in the non-rotational motion. This is non-rotational motion, linear motion, and this is rotational motion. Okay? So basically now, if there's no torque acting on the alpha particle, that means the angular momentum will be constant. Angular momentum is given by m omega r square, which is constant. So we can write this as mr square d phi by dt. Replacing this omega with d phi by dt. We said over here that d phi by dt is omega. And then we would write this basically, how will we write this now? Let me erase the board. Just 1 second. We basically write this as, we know that V is equals to R omega, right? In rotational motion. Ab sabne rotational motion padha hai pehle? V is equals to R. Okay, V is equals to R omega, ठीक है? So, यहाँ पे जो हम कह रहे हैं यहाँ पे that m r square omega will be equal to what? It will be equal to m r times v. Yes.
ये angular momentum के equal है.
Yeah, this is angular
momentum के equal है.
Angular momentum. Yeah, as equals to mvr. So m and our r here, what is our is equals to mv, and what is our r here? R is b, right? It's the impact parameter. Yeah. R. So we get now. So basically we know that V is equals to R omega. So m r square omega will be equal to m times ये जो V is equals to R omega इसमें डाल देंगे, so we get left m r v, yes, which is equals to mv times, and our radius here and our r distance here is equal to our impact parameter, because that is the closest distance to which it comes, right? यहाँ तक समझ में आ रहा है सबको? ये हमने किस तरह से फॉर्मूला कहा है यहाँ पे? So if this is r m omega r square, which is constant, is equals to m r square times d phi by dt is equals to mvb, ठीक है? From this, अगर हम इसको rearrange करें, so we will get dt by d phi is equals to m will cancel, we'll get r square over vb, ठीक है? यहाँ तक ये समझ में आ रहा है? Substituting this expression, now we had before in this formula, we had dt by d phi. Now we want an expression for dt by d phi, so that is exactly what we have done here. So dt by d phi gives us this expression. So now we will put it back in here. Sin theta over 2, यहाँ पे उसको v square b, यहाँ पे vb जो था उसको यहाँ पे ले गए हैं इस साइड पे, and then we get here f r squared, where did that go? F r squared cos phi d phi. ये समझ में आ रहा है सबको? यहाँ तक समझ में आ गया? Now this Rutherford scattering formula is quite long, ठीक है? And we still haven't finished it yet,
Yes,
ठीक है? It's very long, so basically I don't think I will ask you to derive the whole thing in an exam, okay? It's too long, so maybe if I do ask you in a quiz or something, then I will ask like maybe some parts of it, okay? Or maybe I might give you some steps or maybe one formula or some formulas in between or something, okay? So you just have to, it is very long, but we have to do this because it's in our course, okay? So now, as we recall, now we have this formula, ठीक है? हमारे पास ये formula आ गया है, ठीक है? Now we want expression for F. Now F हमें नहीं पता कि क्या है अभी तक. So we know that it's electric force exerted on the nucleus on the alpha by the nucleus on the alpha particle, and the alpha charge in the nucleus is Ze, ठीक है? E is the electron charge, and Z is a number, is the atomic number Z. So we don't know what the Z is right now. Okay? It can be any, it can, whatever the nucleus is consisting of, जो भी हमारे पास मेटल जो भी न्यूक्लियस होगा उसका जो atomic number होगा उससे हम multiply करेंगे E से. So basically our electric force will be given by this equation, where we know that. Why did we use 2 here? Because we use 2 here because alpha particle में 2 protons होते हैं ना, 2 protons होते हैं. So we used Ze for the nucleus and 2E for the helium nucleus, for the for the alpha particle which has charge of 2E, right? Because we said that it has lost 2 electrons. So and this is the force, and divide by 4 pi epsilon 0 r squared. So this is the electric force. This is the electric force exerted by the nucleus on the alpha particle. When we substitute this equation in here, what will we get now? ये जो 4 pi epsilon 0 है, ये हम उस side और Z E squared 2Z E squared ये हम उस side पे ले जाते हैं. We'll take it to the left side of the equation, ठीक है? ये 2 यहाँ पे पहले था, ये अब इस 2 से cancel हो जाएगा, ठीक है? ये हमारे पास ये equation आ गई है. And how did we get, and now how is this equal to 2 cos theta over 2? इसको बस integrate करेंगे ना. Cos phi becomes sine phi, right? Cos phi becomes sine phi, and then you just put the values in there, right? It'll become sine theta minus pi over 2 minus sine theta minus sine minus pi minus theta over 2 हो जाएगा ना. And then sine of minus any theta is equals to minus sine theta. तो वो ये term minus हो जाएगा, plus हो जाएगा. And then if you just do this integration, it's very easy to solve, and you will get 2 cos theta over 2. ये सबको हो सकता है ये solve. ये मुश्किल तो नहीं है ना ये. It's just integration of cos phi with these limits, ठीक है? So you will get 2 cos theta over 2. And then when you divide, if you divide cos theta over 2, ये 2 इस side पे ले जाएं, ये जो 2 है इससे cancel होकर 2 हो जाएगा, और ये cos phi theta over 2 divided by sine theta over 2 becomes cotangent. 1 over tangent is cotangent, right? You know that, right? So cos theta over 2 divided by sine theta over 2 is cotangent theta over 2, which is 1 over tangent. So अब हमारे पास ये formula आ गया है. ठीक है, it's more convenient to specify the alpha particle kinetic energy instead of its mass and velocity separately. Basically, alpha particle की mass यहाँ पे we see mv square over here, ठीक है? इसके बजाय हम 2 kinetic energy डालते हैं. We know that kinetic energy is half mv squared, right? So 2 times kinetic energy is equals to mv squared. ठीक है? ये equation हम इसमें mv square यहाँ पे mv square इसकी जगह 2 kinetic energy डालते हैं. So we get 4, ये 4 जाएगा, and we get this equation. Any questions up till here? Now we have an expression for B in terms of theta, and that's good because we wanted that equation, right? Any questions related to this so far? Okay.
Question तो नहीं है बस.
Okay. Then equation 4.29, which is this equation, ठीक है? Now it cannot be directly confronted with experiment because there's no way of measuring the impact parameter corresponding to a particular observed scattering angle. Now, अब हमारे पास B ये जो है BA, we don't really know, we can't really measure B, ठीक है? Wait just one second. What do we have to do over here? Basically, we want to get rid of the B. Our final expression for the number of alpha particles for this n theta, which was equal to the number of particles, right? It was the number of particles that reached the screen per unit area. Where did it go? Yeah, it's the number of alpha particles per unit area that reach the screen at a scattering angle of theta. So this is independent, as you can see, it's independent of B, okay? So basically, what we're saying now is that we cannot really measure B directly. So there's no way of measuring the impact parameter directly because experiment में तो किस तरह से हम measure कर सकें कि nucleus का distance alpha particle से कितना है, ये experiment से नहीं हो सकता, ठीक है? So we have to use an indirect strategy. We have to make use of an indirect strategy to find B, ठीक है? To find what the value of B would be, ठीक है? So basically now, where are we? Yeah, ये हमारे पास ये है so far B in terms of theta. And now what we're going to do is that we will, our first step is to note that all alpha particles approaching a target nucleus with an impact parameter 0 to B will be scattered through an angle theta or more, where theta is given in terms of B by equation 4.29. Yes, so B is given by equation 4.29. ये हमने already derived कर लिया है, ठीक है? So now if we have this diagram that looks like this, ठीक है? यहाँ पे हमारे पास target nucleus है और ये अगर path है, obviously the gold foil different paths हो सकते हैं, ठीक है? Depends on the like beam depends on the incoming beam, ठीक है? तो ये beam है यहाँ पे, and this is the distance B between this is the impact parameter, the distance between the incident beam and the distance between the incident beam and the nucleus, ठीक है? So that means that our first step is to note that all alpha particles approaching a target nucleus with an impact parameter 0 to B. Impact parameter can be from 0 to B, right? Because जो भी values होंगी B can be like the alpha particle can be incident directly on the nucleus as well. In that case, the impact parameter would be 0. And then it would deflect very largely. It would have a large deflection. So the impact parameter can range from 0 to B. We want to figure out what actually B is here, okay? Will be scattered through an angle of theta or more, where theta is given in terms of B by the equation. So theta हमने define कर दिया था in terms of B. तो जितना ज़्यादा B होगा, for example, अगर B ज़्यादा है, impact parameter ज़्यादा है, I think the theta should be smaller, right? नहीं. It depends on how should B vary with theta, according to our equation that we have over here. अगर B ज़्यादा है, ठीक है? फिर तो अगर B कम है तो the deflection should be larger, right? Theta क्या हो जाएगा इस situation में if it's going exactly backward? If it's going exactly backward, theta is what? 180 degrees, right? Well, anyway, that is the relation between B and theta that we found. But what we're saying here is that this means that an alpha particle that's initially directed within the area pi b square around a nucleus will be scattered through theta or more. Now, if we look at this diagram over here, we will define a term known as cross-section, okay? Which means that it is an area for the interaction, okay? Like for example, अगर यहाँ पे हमारे पास B है, ठीक है? B impact parameter, then pi, if we draw a circle of radius B around that nucleus, then pi B squared will be the cross-section of that, will be the cross-section for the interaction. And what do we mean by cross-section? It's basically the area over which the interaction is taking place. Make sense? So we will give a symbol to the cross-section, which is sigma, and so we will call it sigma is equals to pi b squared. Okay, so ये यहाँ तक हो गया है. And then what we want to do now, it's going to be a little bit more difficult from here onwards, ठीक है? We will do an example as well, and then we have to consider cone like this and also these things here. So we have to consider a foil thickness T. Any questions up till now? ये cross section में कोई मसला तो नहीं है ना? ये आसान है definition इसकी. ठीक है? I hope that no one is confused regarding anything that we have done. Sumer, you had a question? Or we will ask it after we finished all this, after we finish this whole thing. I think he's not here. Okay, well, so we will consider a foil thickness T. So, for example, if we have a foil.
Ma'am, time हो गया.
Time हो गया है.
Yes, ma'am.
तो फिर ये हम बीच में रुके हैं. ये भी है. ये भी थोड़ा सा ज़्यादा रहता है. ये हमें करना है. फिर ये भी करना है. एग्जाम्पल ये भी करना होगा. और ये तो अभी तक कोई क्वेश्चंस तो नहीं किसी के पास regarding anything we have done so far, the Rutherford scattering derivation जो हमने अभी तक complete नहीं किया. हमने अभी तक basically यहाँ तक किया है, which is B expression for B impact parameter in terms of theta and cross section यहाँ तक किया है. तो फिर slide 20 से फिर हम next lecture में करेंगे. ठीक है? Any questions? No questions?
हाँ मैम, मेरा हार्मोनिक
Yeah.
ऑसिलेटर में से क्वेश्चन है.
Yeah, okay. Yes. Any one of you?
मैम
Yeah.
कोई और भी बोला था.
I don't know. Any one of you can speak.
मैम जो
Hello? आवाज नहीं आ रही.
Mic तो on कर लो.
Your mic is muted. Okay, now.
मैम किसी ने म्यूट किया था.
Okay.
Equation 5.67.
5.67 वो कहाँ पे है? Quantum mechanics ही है chapter में.
मैम मैंने हार्मोनिक ऑसिलेटर का कहा था, वो पिछली स्लाइड है.
ये okay, so yes.
मैम उसमें ये जो इसने अल्फा और वाई की वैल्यूज निकाली हैं ये आ नहीं रही.
You're probably asking like ये क्यों यूज किया कर रहे हैं हम?
नहीं वो इसने कुछ करके जो अल्फा की वैल्यू आई वी और वाई की जो फाइनल वैल्यू है वो दोनों आ नहीं रही ऊपर से.
अच्छा, मतलब कि इस फॉर्म में नहीं आ रहा?
जी नहीं आ रहा.
नहीं आ रहा
क्योंकि अगर आप अल्फा को देखें तो अल्फा इधर बनता है 2me/h² और उसको इसने लिखा हुआ है 2e/h फ्रीक्वेंसी आगे, और वो नहीं इक्वेट हो रहे.
Are you sure? ये फिर बुक में गलती की होगी फिर. Square root 2m.
या तो कोई ऐसा फॉर्मूला यूज किया जो मुझे नहीं आता, या फिर कुछ और हुआ है.
Basically k, so y is this thing square root times x, so y squared would be km divided by h bar squared. So km divided by h bar squared. ये 2 ये फिर सही हो रहा है ना? y तो ठीक आ रहा है. And alpha के लिए we have 2e over h bar square root m over k. M over k, alpha is not squared, so
तो है ही नहीं.
E over m.
m over k इक्वेशन में है ही नहीं. मुझे नहीं पता ये कहाँ से आया m over k.
2e over h bar. Let's see. Alpha is 2e over h bar. It should be h bar squared, right? And there should be an m.
Yes.
Yeah. Basically, they're saying that they're using one of the previous equations, I think so. Like this one, right? Frequency is equals to k over m, right? Frequency is equals to k over m. So this will be equals to, wait a minute. 2 pi times frequency is equals to square root k over m.
Ma'am, frequency is equal to k.
Yes.
Yeah.
This mu here is
Yeah.
frequency. Yes. So frequency we said was equals to 2 pi. Yes, 1 over 2 pi squared k. Okay, I will check this then. I'll have to check this. It'll take some little bit of time to get. I will check this, but it seems that they put for
मैं y
square
को भी
root
देख
k
लें.
over m.
y भी यही नहीं आ रहा.
Y भी ये नहीं आ रहा.
y भी ये नहीं आ रहा.
2 pi तो नहीं आता
उसने
है.
देखे ना, उसने जो उसने फर्स्ट इक्वेशन लिखी है उसमें उसने h लिखा हुआ है और उसके ऊपर स्क्वायर रूट है. अगर आप स्क्वायर लेंगी ना y का, जो उसने एंड y लिखा हुआ है, तो h बार आ रहा है, लेकिन ऊपर h बार स्क्वायर है.
Okay, I will check this then. I will let you know, ठीक है? But basically, ये जो harmonic oscillator और ये जो finite harmonic oscillator is not so important, but still we should know how to do these things, ठीक है? I will just check these and I will let you know on the next lecture, ठीक है? Or maybe on WhatsApp I will just check in and send it to everyone, ठीक है?
मैं आगे मूव नहीं करता किसी टॉपिक से अगर वो सॉल्व ना हो रहा हो, तो मैं स्टक हूँ इधर. मैंने आज से आगे कुछ भी नहीं किया अभी तक.
मतलब कि आपने क्या नहीं किया? Atomic structure नहीं? Atomic structure तो में कोई question
जी, atomic structure वो मैं कर लूंगा, लेकिन मैं स्टक हूँ बिल्कुल इसी इक्वेशन के ऊपर. ये
okay. I will check this. Yeah, I will check this. And maybe the book has made some mistake or something over here. Okay, 2e over h bar nu. Yeah, I have to check this. Okay. So, are there any other questions? Someone else was also saying something before.
Okay, ma'am.
Yeah. Someone else also had a question. Let me download the attendance list also. No one has a question. Okay, then we will continue on. Monday. Okay? And maybe I will give you, maybe there should be a quiz, but first we should finish this atomic structure topic, and then we should have a quiz, right? On this atomic structure. Or should we have a quantum mechanics quiz on sometime next week? Okay, so for next week, maybe we'll have a quiz. Can we have a quiz on, say, Wednesday next week? Because we will finish this derivation of the Rutherford's, like this PowerPoint, ये वाला PowerPoint है, इसको हम Wednesday रख सकते हैं quiz इसके ऊपर. हम जब तक कि Monday को 23 ये complete हो जाएगा ना, ये derivation Monday को. So atomic structure के ऊपर इस derivation, this PowerPoint, which is lecture number 6, ठीक है, uploaded in the MS Teams, इसके ऊपर quiz हो जाएगा Wednesday के ऊपर, ठीक है, Wednesday को, ठीक है? Okay, I hope that's okay with everyone, ठीक है? So, yeah, I think that's all for today, ठीक है? Okay, Nafis. So I will write in the group that there's a quiz on Wednesday on this atomic structure topic, because we'll finish it by Monday. ठीक है?
Okay, ma'am.
Okay. Hafiz.
Hafiz.
Okay, ma'am. Allah Hafiz.
Hafiz.
Allah Hafiz.
Hafiz.